So in this video, I wanted to focus on what if it's not e to the x? What if it's a different constant base besides e? So I'm going to say, let's let the function f equal a to the x, where a is just a constant that's greater than 0. And it could be e. You'll see that it'll still work even if it's e, but it just needs to be a constant that's positive. So I've typed out here what's happening, but most people don't do this part. Whoops, sorry. Most people will end up just memorizing different steps in the end result here. But I wanted you to see where it's coming from. So we have a function a to the x. Since e and the natural log are inverse of each other, that means they would cancel out. If I raise e to the natural log of a to the x, e and natural log would cancel out, leaving an a to the x, which is we would normally have the right-hand part and go to the left, but equations work both ways. We're actually going back this way. We're unsimplifying it. But then we have a power property for logarithms that says that if I'm doing the natural log of a to the x, the exponent inside can come down in front of the natural log. So my a to the x, which is e to the natural log of a to the x, is the same as e to the x times the natural log of a. But then the natural log of a constant is still a constant. So we actually know how to find the derivative of this because we have e to a variable power. So the derivative of e to the variable power is itself times the derivative of the exponent. But e to the x times natural log of a is the same as a to the x. So the derivative of a to the x is itself times the natural log of a. I will admit, the majority of people don't do all of this work. People just memorize that this is the derivative. The way I think of it is the derivative of an exponential is itself times the natural log of the base. Remember, exponential is constant base variable exponent. This will even work with e. If you have trouble remembering the derivative of e to the x, it would be itself times the natural log of e, but the natural log of e is 1. So examples of this. I have an exponential, constant base variable exponent. So its derivative is going to be itself times the natural log of the base, but then I need to worry about chain rule times the derivative of the exponent. So this part is for the exponential, and this part is from the chain rule. So then if I want the derivative of 4 to the inverse tangent of x, that's a constant base variable exponent, so its derivative is itself times the natural log of the base, but then I need the derivative of the exponent because of chain rule, and there's our derivative. One last example here. It's an exponential, constant base variable exponent, so the derivative is itself times the natural log of the base times the derivative of the exponent. And there is our derivatives. Coming up next will be logarithms, and there'll be a few videos to go over that.